Hey everyone, Mr. Ekstrom. Going over the central limit theorem in chapter 9, especially as it pertains to means. This is page 515 in the book, and it's a really important page. I recommend you take a look at 515 yourself. But here is a population, and basically we could think of this as sampling individuals, and that is a sample size of 1. So I could pick, and by the way, this is something like 1,800 different stocks, and some of these stocks did well with a 40% return, 20% return, but 1987 was not a great year, and so the average here, the average return is something like a negative 5%. If I can get this thing to draw. But it is a normal distribution with the risk of making profits on the right and losing money on the left. Now, out of these 1,800, we could take samples, or they call them portfolios, of 5 stocks. So this is samples of size 5. And what the central limits theorem says is that even if you have a good probability over here of having a negative 40%, 60%, or even 80% return, when you put together 5 stocks and average their return, sure, you might have a negative 75 in there. You might have a negative 50% return. But with the random mix of 5, you are also likely to have a 0 and maybe a positive 10. And the fact that you've picked a negative 75 is going to be balanced out. I don't know, let's throw another one in here, say negative 5. Well, those are going to average out to, this would be a sample average. I just paused this to run those numbers in the calculator, and the sample there is only negative 24. So, even with some negativity coming from the left side here, when you have a sample size of 5, the numbers are just going to average out, and these tails are then pulled in. So, that particular x bar, negative 24, would land here. So what we see is a spread here, and I did put this in my calculator to get an approximate standard deviation of 27. I guess this is actually 27 percentage points. Well, look at and let's see if we can't change color here. What kind of standard deviation do we have here? Well, the central limit theorem says 2 things. One is that as we take these samples of 5, that average is not going to change. We expect our samples to average that same negative 5, negative 4%, whatever that was, something below 0. But, you can see the spread, the extremes are going to be much less likely. And so the standard deviation of all these sample means is going to be that population standard deviation cut down by a factor of square root of sample size. Now, square root of 5 is just a little bit more than 2, something like 2.2. And so if we put in 27 divided by square root of 5, it turns out that this standard deviation is closer to 5. That's approximately. And that's it. There are 2 things. And one is the mean equals the mean, and the other is that sigma does not equal sigma when you're talking samples. Sigma equals sigma divided by square root of n.